我们从科技业还有金融业探讨完 AI 之后，我们现在要来思考，究竟企业在经历 AI 部署到规模化的过程当中，会经历什么样的挑战呢？那今天我们的主持人高嘉良 Infuse AI CEO， 他要来，高嘉良可以上台，他要独挑大梁坐在这边，然后我们三位，大家已经看到来宾已经在线上了，三位要透过线上接受高嘉良的访问。好，那今天三位来宾大家可以看到，分别是 Y-Data 的 Founder and Chief Data Officer 是 Fabiana Clemente， 还有 Lending AI 的产品副总裁杨凯，以及 Fast Financial Group 的技术总监 Angus 龚。我们要来探讨 AI 部署到规模化时候会遭遇什么挑战。好，高嘉良。
Hello, everyone. So I'm CEO and co-founder of Infuse AI, and we manage the complexity of AI workflow seamlessly, so the AI practitioner teams can collaborate to focus on really solving business problem. Today, I'm super excited to host a unique conversation about AI deployment challenges here at the Galaxy Summit. So over the past few years, we've seen tremendous growth in data and AI tools, proliferation of so-called modern data stack, and the whole ecosystem of ML-related tools such as data labeling and like visualization, feature store, training workspace, so on and so forth, and reverse ETL even, and now as well as vertical specific solutions. However, making models reliably into production and keeping it up to date remains quite a challenge and very time consuming, a lot of manual repeated effort. So here today, we have a really unique lineup for the panelists from like vertical data tools and horizontal data tools, and also leading experts in companies that actually put AI into use, consumer-facing use. So please allow me to introduce the panelists, Kai from Lending AI, and they're building the AI solution for manufacturing. Also Fabiana from Y-Data, specialized in data quality and synthetic data. Also Angus from Fast Financial, overseeing the company's data and AI strategy. And he also led various teams before in MarTech, e-commerce, and healthcare. So I'd like to invite each panelist to give a quick background of yourself before we dive into the topic. Over to you, Kai.
Hey, thank you, Jialiang. Hi, my name is Kai, Yang Kai. I'm from Taiwan. More precisely, actually, I'm from Taipei, Nangang, not far away from where you guys are. Very happy to be here. I'm currently running the product team in Lending AI. As you know, that Lending was founded by Andrew Ng and has been helping several industrial customers adopting AI since 2018. I joined Lending in 2019 and started the product team in mid-2020, actually right after the pandemic happens. So since then, my team and we have been working on developing an end-to-end MLOps computer vision platform we call Lending Lens. Today, Lending Lens, our platform has been successfully deployed in many manufacturer customers to help their AI team or their quality inspection team to develop, and more importantly, to deploy a visual inspection solution based on deep learning in the production line. For me, in addition to the product function, I also oversee the business and sales in Asia. Before joining Lending, I actually co-founded my own AI startups and focus on biological applications, specifically in cell counting and cell sorting, and has been adopted by one of the largest pharmaceutical companies in the US. Before jumping into AI, I spent 15 years in semiconductors and chip design automation. I actually work very, very closely with many chip design houses in Hsinchu. Before that, I got my PhD at Santa Barbara and got my degree in Tsinghua. Very, very glad to be here and share what I've learned for the past few years about AI, and most importantly, about AI deployment.
Thank you. And then it's actually midnight, past midnight for Kai and Fabiana. And so next up, Fabiana.
Hi. So I'm Fabiana Clement, Chief Data Officer at Y-Data. We are helping to build a data-centric platform that accelerates and increases the ROI of AI solutions by improving the quality of training data sets. Personally, I'm actually from Lisbon, so all the way from Portugal, currently based in Seattle. My background is in applied mathematics. And well, since I started working, I've been dedicating my professional career to data science and also to data solution architectures, both in big enterprises and startups.
Right, thank you. And last but not least, Angus.
Hey, hello, thanks for your call. To be honest, I forgot to prepare for self-introduction, so could be a bit messy. Anyway, so I just start from what we are doing right now in FFG. So the Fast Financial Group, we are the company trying to provide the all-in-one financial services platform to the end users like SMEs, small to medium enterprises. Yeah, so what we are doing right now, we are focusing on using the leading edge technology like stablecoin to empower the all the financial services we're doing right now and more payments. Yeah. So as for myself, I think I'm more like well, people used to look at me like a data scientist, but I'm always looking at myself more like a engineer. So I spent 8 years in Google. The first team was Android, working on Android camera. So probably many of you used my product before. And then I moved to Google Research. Now I think it's related to Google AI. So my team, we didn't do too many things. We just do a few things. So it's more on the NLP. So the first product our team launched was the Gmail Smart Reply on mobile phone. So it was a very interesting experience because actually at the time, we were competing with Google Brain Team, and we were lucky to win the first battle. And later, we launched that technology into Google Assistant. So when you say, OK, Google, sorry, I need to be careful not to activate my phone. Yeah, now it's active. So yeah, when you say, OK, Google, and try to say some random things, then we'll kick off our language understanding engine and try to respond with some meaningful sentences. And the final product we pushed out is the Universal Sentence Encoder. So it's actually the underlying technology behind these two products. And we made it publicly accessible on Google Cloud. And then after Google, I joined different companies in different industries, like Tokopedia, the unicorn in Indonesia, to lead the data science team. Or I think many people in Taiwan also know about Appier, so the targeting martech company. And previous one is a big data and AI company in healthcare. So it's that, yeah, I jumped between different industries, but I learned a lot. Okay, thank you.
Well, so you can see from the panelists, we really have a going to have a really rich discussion. So I think let's get started. I think the first topic will be like, what can you share about? I actually prefer a failure story or like horror story for AI in production. Maybe Kai can share some of your experience.
Sure. Thank you. Actually, for me, I have been deploying several AI or machine learning projects in different domains, such as healthcare, retail, pharmaceutical, and manufacturing. Some of those projects that I was involved with were pretty successful, which means they were running on the production line and generating values. But at the same time, some of them, probably actually most of them, many of them just fail horribly. So although the problem I was talking about, or AI model itself could be different from project to project, but now when I look back, actually I can start seeing those challenges are actually converging. So either when we do visual inspection for manufacturing, computer vision for manufacturing, or offer patient predictions for healthcare providers, or develop recommendation engine for retails, one of the most challenging part that for me is to setting up the right expectation and having a corresponding tool and infrastructure, in this case, ML ops, to support those executions. So what does it mean by expectation setting? So for all the applications that I have been involved with, it is safe to say that none of those models work right at the first place, right out of the lab that we are working on. Whether these are the computer vision project or recommendation, it is really, really critical to have this common understanding with your boss or with your customers. If the boss or the customer is betting a magic or want a home run right out of the box from the first model, it usually means that I will have a very, very painful project, and this project likely will fail. For example, give you a very concrete example. We have a visual inspection project. Customer give us 3,000 images and expecting to get 99.96% recall and less than 1% overkill right at the production line in 3 months. Right? This is simply just asking for failures. But for me, actually no one that guarantee that data distribution that we got from these 3,000 images are similar, even close to the production line data. So we Landing have been through this scenario for more than 1 time, and each time failed just horribly. We failed to set the expectation with our customers. It turns out our customer is very, very mad at me, and even worse, my machine learning team is getting very, very mad at me. So on the other hand, a similar expectation case where we set the right expectation with customer, said we deploy the first model in the shadow mode, where the model make prediction but do not really make the decisions in the production line. And then we use the right ML ops platform to in the production line collecting the new data, fine-tune the model, and use the ML ops to facilitate the performance monitoring. With this engagement, this expectation setting, it turns out to be a win-win for both my team and my customers. So the most common and challenging part for AI deployment to me, seeing so many projects, is expectation setting. And having us or our customer to invest on MLOps infrastructure to execute those projects is kind of the most critical challenge that I've seen for many projects.
Well, thank you for sharing. It sounds like more like somewhat less technical, but also requiring the technical infrastructure to enable people to communicate the technical, non-technical part. Yeah.
Yes, cross functions.
Yeah. So yeah, great. Fabiana, do you have any? Well, I would prefer failure story to share for putting models into productions.
For sure. Unfortunately, I guess the majority of my experience were around failures, at least seeing those happen. And I guess from my experience, those always happen for 2 main reasons. Expectations, which it's not that different from what Kai was here sharing with us, but also about the data. I do recall one specific example that I do think to be one of the most interesting ones. I was working on location data, and there was this expectation from management that we could build this super developed machine learning model that could just understand the behavior of people based on the location data. Sounds amazing. But when you are dealing with very noisy data, a lot of missing periods, and above all, data that does not have the right variability for what you want to build, it's when this assumptions of what you want to build starts to crumble. In that case, there was this specific assumption that I do recall, which was volume or big volume equals to quality, and equals to, yes, we are able to build this use case, which was not true. So essentially, if I were to build any model out of that data, I would just have a hugely biased kind of understanding of the human behavior. And that, well, if it reached to production, would just be a failure. Of course, broadly speaking, that model didn't went to production. Happily, I was able to prove my point. But anyways, I guess it's very difficult for data science teams, for example, to manage these expectations. How can they just show when the data is not good enough that some work needs to be done? And above all, how can they just, pick up the data they have and make it work? Or at least start iterating on that data in order to make it work, even if that means some months of investment, of course.
Right, thank you. And then, so yeah, I heard a joke about like data scientists spend like 80% of time preparing data, and the remaining 20% of the time complaining about preparing data. Right? Is that true, Angus? And then can you share like a few failure story from your experience?
Yeah, I guess the real failures sometimes lies in the process or before launch. So a few things I guess I can share, like for example, when we were building the Gmail Smart Reply, there's something interesting. So I actually thought about this many times. So data science or machine learning or AI solutions are very risky. Lots of risks inside. And for example, performance, you cannot always control. Your data is alive, right? So your model has to also be alive. So from time to time, the data changed, the distribution changed, then the performance will change. But here I'm talking about one thing that's specifically sensitive, that is bias. It's not very easy to spot because you only have what you have, right? The data you have. And also you have to be creative to spot this bias in the model. So one example is that when we were building the Gmail Smart Reply, we also try to see if it has some bias there. So for example, we put in the Gmail, the mail content, no, sorry, not content, actually title. We put in executive meeting. And then in the content, the model will try to suggest many sentences start with he, but if you put in housekeeping, blah, 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 then it will start with she a lot, right? So this is obvious that kind of bias we don't want, but how somehow it comes from the data. And if you are not familiar with the problem you are dealing with, you actually don't know how to spot this kind of bias, right? And you have to first to be creative enough, then you know how to test to find out these kind of the bias. So in the end, we started a small group to attack our model to find out all the possible bias and create like a standard data set to test. So I think I just want to add something here. I think there's sometimes the bias and then of course the unpredictable predictions, right? So you always don't know what will come out from the model, especially it's like a learning-based model. Right? So yeah, be prepared.
Yeah, well, thank you. So yeah, bias, I think that's like a whole different panel worth discussing because I mean, like if the data we're working with is already biased, then there's, well, we'll need to do extra effort to do that, right? And then speaking of, I think we talk about like the practice, the expectation, and also coming back to data, and then data quality, and then also Andrew has been like very vocal about new, like in the industry is converging into like so-called data-centric AI, where we should spend more time like making sure our data has good quality instead of like iterating through different ways of modeling. And then I'm just like also like Y Data was just also starting the data-centric AI community. And then I think that's really great that the convergence is happening. People are looking at this. So, but like there are some critiques on that because like, of course, data is important. It's like the source of our model. So I want to like maybe ask for your opinion about like, is data-centric AI a new thing? Why are we emphasizing it? What does it mean for production? Is it like just like the all important things being re-emphasized? Over to you, Fabiana.
Well, I have to say that I guess the concept that data is important for the development of machine learning solutions is not new. So after all, every single one of us have at least heard this one time, garbage in and garbage out. So that's something, it's a common knowledge. But I guess that conceptually, for me, what changes with this new focus or of the AI lifecycle development, where data is the central object and the focus of iteration. That's for me what means to be data-centric. So instead of focusing so much on the model, which is usually the path to build this model-centric kind of strategy, where you do focus on getting your hyperparameter tunings selected, selecting really well your model, after just preparing the data once and getting it ready for the models, in a data-centric approach, you kind of assume that your data is the artifact that you want to iterate upon. So all the research that is done towards better AI or improvement of the models is held in the search phase space of the data information. So you are working under the assumption that your data can be improved and can be denoised, let's say. So every investment is done rather throughout labeling, for example, managing or better data management, profiling your data, getting acquaintance with the data that you have available so you can avoid inconsistencies or, for example, even detection of biases so that does not translate to the model, or you are just slicing, filtering, and so on and so forth. So this is for me what it means in terms of doing a data-centric development. And that's for me what changes. So it's the paradigm of development, let's say. That would be for me the easiest way to explain what might be data-centric nowadays.
Thank you. And then I think like the tooling and are actually really shaping into like how we iterate data more efficiently to kind of iterate our process for modeling. So what do you think, like Kai, for like what does it mean for production and like specifically like making it into deployment, and then how does it like data-centric AI change like the paradigm or the tooling required for that?
Oh, thanks. Still pointing out that if you follow Andrew, that you probably have already heard him talk about this a lot, especially this year in the NIPS conference. So here's my take on this topic, right? The high-level concept of data-centric AI is actually reasonably well aware, but the tool and the best practice that support this data-centric movement are relatively new. Let me share with you with some perspectives. First, if you are doing computer vision, you might know that there are likely 100,000 of labeling issues in the most famous ImageNet data set, right? This is the most common, most popular computer vision data set that we use to train the models. And among those 100,000 mislabels, 2,900 of them are actually in the validation set. Look closely, you will find more than 20% of those images actually contain multiple objects, but only label one object there. This is not a trivial amount. However, even knowing this fact that the most popular data set is not clean, we, both academia and the industry, are still using ImageNet as the benchmarking standard. So this is very interesting, right? We know this is a problem, but we still use it. Another angle to look at this is in practice, in the real world, where I work closely with various AI teams. One of the most common questions that was asked me is that if we, Landing AI, or in general, Andrew's AI lab in Stanford, have, they call the model of the month, or the loss function of the month, or the optimizer of the month, so that our customer can adopt them to solve their performance issues. It's very, very common. I got this question almost on a weekly basis, right? So, but after looking into our customer case, it turns out that 99% of the time, the problem is on their data, not on their model, not on their loss function, or not on the optimizer itself. The data problem actually could be very simple bad data quality, such as out of focus images, wrong annotations, inconsistent labeling. For example, one single image contain multiple defects. We can have two different labels label totally different bounding boxes. The reality is that people are really paying way more attention on the algorithm or the model itself and ignore how critical the data is. to support this argument, my team actually about 6 months ago actually did a quick research. So we look at all the AI papers in the archive for the past 5 years. And we look at it, we find that only 1% of the paper in the AI community now talk about data. The rest of 99% are talking about model-related technologies. Therefore, I think what we think is the reality is that the AI community is aware of this. Data is important, data-centric, but it does not have the right tool. It requires very sophisticated tool to systematically surface all those data issues. Could be a problem, could be a label, could be data quality problem, and then solving those problems accordingly. So actually, this is the direction that we, Learning AI, is focusing on.
Well, thank you. I think so. The refocus on well, maybe just straight data engineering towards like quality engineering, even if I might call that. So, what do you think, Angus, about like what is this new trend, or is it like impacting your daily work in like making models into production?
Yeah. So, not sure if you noticed. I think when Fabiana was talking about this, it's not something new. I was laughing because. Yeah, it's not new to you, Fabiana, but it's actually new to many people in different industries. So data-centric AI, just for this topic, I went online to search for this term, try to understand what it means. And it's interesting. I think people now in different industries, we are finally picking up the very important concept, the garbage in, garbage out, right? This concept has been there since 1957. But luckily, we are all learning about it right now. So I think it means that in the real world AI, we are finally having a powerful tool, powerful enough tool. So we don't look at the modeling anymore. Now we look at where we got the garbage. So we try to make sure that the data is useful, it's the right data. So a lot of things we're talking about today is data engineering, data modeling. And this is a very clear sign to me that the AI is the modern machine learning solution is becoming a commodity every day. So which is good. I think it will increase the quality of our life as a human. Yeah.
All right. So as the like kind of the foundation models or like the state-of-the-art model become more commoditized, and then I mean data is really the key to have the fine-tuned result, do what you want. So I think we have really great lineup today, like everyone from very different perspective. And then I'm just curious if you have questions for each other.
Oh, sure. I can start one to Fabiana. So I think about synthetic data, right? This is a pretty hot area that we are facing today. Actually, I think the common question we have is, for synthetic data, is it a chicken egg problem? It does mean that does our customer, do we need enough initial data to enable generating very realistic data, synthetic data, for example, using GAN-based? Right? How do you see that apply to those applications which just do not have enough data to starting with? We can see that the synthetic data can be applied very successfully in retail, where they have initial large data set. But how about those very domain-specific applications? Can you share some of the experience you have?
Yeah, for sure. That's a very interesting question, especially as you mentioned. So the chicken and egg problem it's a reality. But let me see if I can scope the question especially in the area I'm more knowledgeable, which is structured data. So I'm not talking here about images or text. So I guess synthetic data can be helpful in solving cold start problems when we are considering small ground truth data sets. So using the right techniques, we can augment very small data sets. Of course, we have to take into consideration this is a trade-off. There is until a certain extent that you can increase, that's for sure. However, when it comes to scenarios where there is no data at all available, it might get trickier. Let me maybe deconstruct this a bit more. So synthetic data that closely mimics the real data behavior, or smart synthetic data, as some might call it, needs definitely, as you mentioned, especially when we are talking here about GANs, a ground truth data set to learn from. For cases where there is a total absence of ground truth, this approach is completely out of scope. So I wouldn't say it is possible, because it isn't. Nevertheless, this is where we touch a bit the realm of simulation or rule-based approaches that, although are not optimal or do not follow totally the reality, as long as you have business knowledge, you are able to create useful data sets to start something out of it. Of course, this can be useful to accelerate your teams to develop something. So while you collect, for example, data, you can start right away doing some initiatives in trying to understand better your population. For example, this was done in entities such as CERN, and even for COVID-19 research, for example. But also we can be dealing with problems around cold start. There are, for example, related with privacy constraints. So the data exists, it is not accessible. In those cases, the generation or the use of techniques such as GANs can be highly useful exactly to unblock, let's say, information without the privacy concerns. It has been proven that the synthesization can work way better than traditional anonymization tools in what concerns re-identification. So I guess that's one of the very useful use cases for synthetic data to break that cold start problem. But we also can see other usefulnesses, such as, when you do have a small data set, you want to augment it because you have it well labeled, or at least labeled by experts in your business domain, and you just want to augment that. You can just, cut the time and cost that would take to collect more data and to label more data, for example. I'm not sure if, this fully answers, but there are always, I guess, possibilities to deal with the lack of data. Sometimes they might not be optimal. Some other times we might find an optimal solution.
Thank you. It does. It does. Thank you.
Cool. Yeah. So I do have a question for Angus, actually. So you are like the kind of someone in the industry that's actually customer facing. So like, and then Kai and Fabiana are from like tool makers. So what is your like consideration when like trying to adopt an AI technology or tool stack from, for example, a more vertical provider or a horizontal, to kind of build and assemble your own platform? And what is your consideration into as a customer for potential this kind of data stack?
Okay. I think when talking about the customer-facing product, it's always very important to look at the customer experience. And for customer experience, one thing we don't want is to introduce something that will eventually affect the customer experience and that we don't have control over that. So most of the time, I will just try to build in-house technology. But on the fundamental part, like for example, infra or other things, I think we, most of the time we would consider that our non-core. So we are happy to work with external parties for that. Yes. So I think, so to me, it's more on, we don't want to build features on top of other solutions. That's my personal preference. And but for empowering my data science team, my engineering team, I'm very happy to introduce external resource.
Right. So yeah, it's super exciting time because we have like explosive amount of different tools that supposedly help us be more productive. But it seems like everyone is like overwhelmed with the number of tools that they need to evaluate and so on. So that was my question. And so I have another question for Kai actually. So realistically for your customer, like how often does it make sense for the new data to come in, and then do you have everything automated for the customer to ingest this new data and then made it into the models that they use live?
Sure. Oh, this is a great question, and the answer is really depends on applications. So let me share with you specific case that I've been working with before. For example, for patient prediction, right, for healthcare, to predict whether a patient will have a certain disease based on his or her medical record, right? This type of problems actually you will find that have very relative few new relationship or information between the syndrome, right, in the healthcare record and the disease itself. So it is important, very important, to validate the AI model that we build in the real world healthcare data, right, in hospital, in the healthcare provider, but not so much have very, very frequent data iteration update on this one, because there's not much new information between the disease, right, and the syndrome. So in this case, we kind of update the data not that frequent, like every month. On the other hand, when I was working with product recommendation, right, this is an ever-changing world. There are new products introduced every day, new event happen every week. So therefore, the whole thing bring a whole new user behaviors every so often, right? In this case, it is so critical to have very, very frequent and rapid data turnaround, so the model can update on latest information and can recommend the latest product that introduced by our customer or by the vendors. So in this experience, this application actually needs almost every other day data turnaround, or at least every week. So it really depends on the application. For manufacturing, right, for visual inspections, right, there's a period of new data introduced period. That's where you need a lot of data to fine tune the model. After that, when the production getting stable, you don't need that many. So it depends on application, as well as depends on when the product or the AI got introduced in the line. Hopefully that makes sense.
Yeah, sure. So I think we have a few minutes before we close. So do any of you have questions for other panelists? Yeah. All right. So I think before we close, I would like to invite each of you to give like one piece of advice for people who are maybe trying to put AI into production or suffering from that, or just getting started to. What is your one piece of advice, Angus?
Yeah, I think something we didn't talk about today, but I just want to mention this. So it's actually a continuous battle to maintain your machine learning solution. So the story does not end, and when it's launched, it's endless. So it's very important that before you have a very complete plan to keep the model updated periodically, you will find that the cost to launch a machine learning solution is very high.
Okay, thank you. And Kai?
Setting up the right expectation with your boss or with your customer is the first critical step. You fail this, the project likely fail. Investing the right amount of software infrastructure like MLOps to supporting the evolution of AI project is also critical. Finally, starting small and improving upon it is another critical suggestion we can offer.
Well, thank you. And Fabiana?
I didn't agree more with what was said. I would just add, work in your foundations, either infrastructure, either data. Both are very important for the success of your project. So definitely.
Well, thank you all very much. And then I think this is a super exciting time. We see initiative like data-centric AI, and then also Fabiana, YData, and us, Infuse AI, both in the AI Infrastructure Alliance. We're building the canonical AI stack for like modern data science. So like micro alliances, different ways of working, interoperation. This is the golden time for making AI into production. Thank you all very much, and thank you for staying up. And thank you, Angus. Thank you.